Welcome to the chapter Integers.
This slide presents the overview of the chapter.
Let us learn about the operation of integers. Operation of integers includes addition, subtraction, multiplication, and division of integers. Let us review the addition of integers on a number line. If we add positive integers to a number, you will move to the right side of the number line. If we add negative integers to a number, you will move to the left side of the number line. Take a number 5 on a number line and add positive integers 2 and 3 to it. We observe that the obtained numbers are right side to the number 5 and they are 7 and 8. Similarly, take 4 on a number line and add negative integers -1 and -3 to it. We observe that the obtained numbers are left side of the number 4, that is 3 and 1. Let us do an activity to represent the addition of integers on a number line. Note: when we add positive integer to the number, the obtained number will move to the right side of the number line. Its representation is as shown on screen. Its representation is as shown on screen. Note: when we add negative integer to the number, the obtained number will move to the left side of the number line. Its representation is as shown on screen. Let us learn about subtraction of integers. Take a number 3 on a number line and subtract positive integers 2 and 3 from it. We observe that arrow is moving to the left side of the number line. Take a number 4 on a number line and subtract a negative integer -2 and -3 from it. We observe that the arrow is moving to the right side of the number line. Let us perform an activity for representing subtractions on a number line. Note: for the given number, when we subtract the positive integer, the obtained number will be left side of the number line. Its representation is shown on screen. Note: for the given number, when we subtract the negative integer, the obtained number will be right side of the number line. Its representation is shown on screen. Its representation is shown on screen. Let us now learn about multiplication of integers. We already know that multiplication of natural numbers like 5 into 2 equal to 10. Here we added 2 for 5 times. Its number line is represented as shown on the screen. We do the same for product of 2 and -3. We obtain its result as -6. Here we are going to add -3 for 2 times. Its number line is represented as shown on the screen. Let us observe the multiplication of integers. Multiply the numbers on the number line with 4. We will obtain -20, -16, -12, -8, -4, 0, 4, 8, 12, 16 and 20. So, we observe that the difference between each successive terms is the same, that is 4. Similarly, by multiplying the same number line with -3, we obtain the numbers as 15, 12, 9, 6, 3, 0, -3, -6, -9, -12, -15. Again, we observe that the same difference is existing between each successive terms, that is 3. From the above two observations, we can conclude that the product of one positive integer and one negative integer is always a negative integer, and the product of two negative integers is always a positive integer. Rules of multiplication of integers. The product of two positive integers always is positive. The product of two negative integers always is positive. The product of one positive integer and one negative integer always is negative integer and vice versa. Let us do a simple activity to choose the correct option for multiplication of integers. Choose the correct option for the following and then click Submit button to verify your answers. The product of a positive integer and a negative integer always is a negative integer. The product of two negative integers always is a positive integer. Let us further discuss about multiplication of more than two negative numbers. Let us assume the numbers -3, -4 and -5 and multiply them as shown on the screen. As we know that product of two negative integers is a positive integer. So, first multiply -3 and -4. Thus, we obtain it as 12. Then, multiply the resultant number 12 with -5 and its product is obtained as -60. In this way, we multiply many negative number of integers. Let us now perform an activity to know the multiplication of more than two negative numbers. Drag the suitable answer from Group B for Group A and drop it in boxes provided against A. The product of even number of integers is always a positive integer. The product of odd number of integers is always a negative integer.
Let us solve a few exercise problems. Click the tab to view solution.
Now, let us study about the division of integers. Division is nothing but the inverse operation of multiplication. We know that the product of 5 and 4 is 20. Therefore, the inverse of it is 20 by 4 is equal to 5 or 20 by 5 is equal to 4. So, for every multiplication statement of natural numbers, there will be two respective division statements. Let us see some examples on division of integers. From the above table, we conclude that we get quotient as a positive integer. when we divide two negative integers. Let us have a look on rules of division of integers. If two positive integers are divided, we get positive integer as quotient. If two negative integers are divided, we get positive integer as quotient. If we divide one positive integer and one negative integer, we get negative integer as quotient and vice versa. So, the rules are the same for both multiplication and division. Let us perform an activity on the division of integers. Select suitable answer from group B for group A and drop it in bracket provided against A. Here, we will learn about the properties of integers under addition. Properties of the integers under addition can be categorized as closure property, commutative property, associative property, additive identity property, additive inverse property. Click each tab to know more. Closure property defines for any two integers a and b. A plus b is also an integer. In the first statement, minus 9 plus of minus 8 is equal to minus 17. It concludes that the sum is an integer. In the second statement, 9 plus of minus 8 is equal to 1. It concludes that the sum is an integer. In the third statement, minus 12 plus of minus 12 is equal to minus 24. It concludes that the sum is an integer. Therefore, the above table follows closure property under addition. Commutative property defines for any two integers a and b. A plus b is equal to b plus a. In the first statement, 5 plus 2 is equal to 7, and in the second statement, 2 plus 5 is equal to 7. And it concludes that a plus b is equal to b plus a. Same for the second and the third statements also as shown in the table. Therefore, the above table follows commutative property under addition. Associative property defines that for any three integers a, b, and c, a plus of b plus c is equal to a plus b plus c. In the first statement, 1 plus of 3 plus 2 is equal to 6, and in the second statement, 1 plus 3 plus 2 is equal to 6. And it concludes that a plus of b plus c is equal to a plus b plus c. Same for the second and the third statements as shown in the table. Therefore, the above table follows associative property under addition. Additive identity property defines for any integer a plus 0 is equal to 0 plus a is equal to a. In the first statement, minus 9 plus 0 is equal to minus 9, and in the second statement, 0 plus of minus 9 is equal to minus 9, and it concludes that a plus 0 is equal to 0 plus a is equal to a. Same for the second and the third statements as shown in the table. Therefore, the above table follows additive identity property under addition. Additive inverse property defines that for any integer a, there exists an integer minus a such that a plus of minus a is equal to 0. Both the integers are called additive inverse of each other. In the first statement, 5 plus of minus 5 is equal to 0, and it concludes that a plus of minus a is equal to 0. Same for the second and the third statements as shown in the table. Therefore, the above table follows additive inverse property under addition.
Knowledge check. Attempt the following questions to check your understanding.
Here, we will learn about the properties of integers under multiplication. Properties of integers under multiplication is categorized into closure property, commutative property, associative property, distributive property, multiplicative identity property, multiplication by zero. Click each tab to know more. Closure property defines that if a and b are two integers, a into b is also an integer. In the first statement, minus 9 into minus 8 is equal to 72. It concludes that the product is an integer. In the second statement, 9 into minus 8 is equal to minus 72. It concludes that the product is an integer. In the third statement, 12 into 1 is equal to 12. It concludes that the product is an integer. Therefore, the above table follows closure property under multiplication. Commutative property defines that for any two integers a and b, a into b is equal to b into a. In the first statement, 5 into 2 is equal to 10, and in the second statement, 2 into 5 is equal to 10, and it concludes that a into b is equal to b into a. Same for the second and the third statements also as shown in the table. Therefore, the above table follows commutative property under multiplication. Associative property defines that for any three integers a, b, and c, a into b into c is equal to a into b into c. In the first statement, 1 into 3 into 2 is equal to 6, and in the second statement, 1 into 3 into 2 is equal to 6, and it concludes that a into b into c is equal to a into b into c. Same for the second and the third statements as shown in the table. Therefore, the above table follows associative property under multiplication. Distributive property defines for any three integers a, b, and c, a into b plus c is equal to a into b plus a into c. In first statement, 1 into 3 plus 2 is equal to 5, and in second statement, 1 into 3 plus 1 into 2 is equal to 5, and it concludes that a into b plus c is equal to a into b plus a into c. Same for second and third statements as shown in the table. Therefore, the above table follows distributive property under multiplication. Multiplicative identity property defines that for any integer a into 1 is equal to 1 into a is equal to a. In the first statement, minus 9 into 1 is equal to minus 9, and in the second statement, 1 into minus 9 is equal to minus 9, and it concludes that a into 1 is equal to 1 into a is equal to a. Same for the second and the third statements as shown in the table. Therefore, the above table follows multiplicative identity property under multiplication. Multiplication by zero property defines that for any integer a into 0 is equal to 0 into a is equal to 0. In the first statement, minus 9 into 0 is equal to 0, and in the second statement, 0 into minus 9 is equal to 0, and it concludes that a into 0 is equal to 0 into a is equal to 0. Same for the second and the third statements as shown in the table. Therefore, the above table follows multiplication by zero property under multiplication.
Knowledge check. Attempt the following questions to check your understanding.
Properties of integers under division. Let us see whether the following properties satisfies the integers under division. Click each tab to know more. Closure property is not followed under division. In the first statement, minus 10 by 5 is equal to minus 2. It concludes that it is an integer. In the second statement, when 3 is divided by 6, the obtained result is 1 by 2, which is not an integer. Similarly, the last statement is not an integer. The above table shows that the closure property is not followed under division. Commutative property is not followed under division. In the first statement, minus 10 by 5 is not equal to 5 by minus 10. It concludes that a by b is not equal to b by a. Similarly, the remaining two statements are also not integers. The above table shows that the commutative property is not followed under division. Division by zero is also not a property under division. In general, for any integer a by 0 is not defined, but 0 by a is equal to 0 for a not equal to 0. So, we conclude that anything divided by 0 is not defined. And 0 by any number is always 0. Its example is shown on the screen. Any integer divided by 0 is meaningless or undefined, and 0 divided by an integer other than 0 is equal to 0. Division by 1. In general, for any integer a by 1 is equal to a. For example, 2 by 1 is always 2, which concludes that a by 1 is equal to a. Similarly, the next two statements conclude the same. The above table shows that if any positive integer or negative integer is divided by 1, gives the same number as quotient. Associative property. In general, associative property is not followed under division. Here, in the first example, initially divide 4 with 2. We get 2. Thus 8 by 2 is equal to 4. Similarly, in statement 2, initially divide 8 with 4. We get it as 2. Thus 2 by 2 is equal to 1. Thus we conclude that A by B by C is not equal to A by B by C. Similarly, the next two statements are shown. The above table shows that the division of integers is not associative. Let us solve some example problems. A person climbs up 6 stairs every second and climbs down 2 stairs the next second. Find the number of seconds required to climb 40 stairs. Solution. Given number of stairs climbed up in 1 second equal to 6 and number of stairs climbed down in 1 second equal to 2. Total number of stairs are 40. Total number of stairs climbed up in 2 seconds is equal to the difference between number of stairs climbed up in 1 second and number of stairs climbed down in 1 second. Thus, total number of stairs climbed up in 2 seconds is equal to 6 minus 2, which is equal to 4. Therefore, time required to climb up 40 stairs is equal to 40 by 2, which is equal to 20 seconds. The temperature of a place was minus 4 degrees centigrade. It went up by 3 degrees centigrade in the morning, then again increased by 2 degrees centigrade in the afternoon and decreases by 1.5 degrees centigrade in the evening. Find the final temperature in the evening. Solution. Initial temperature as minus 4 degrees centigrade. Increase in temperature in the morning is 3 degrees centigrade. Increase in temperature in the afternoon is 2 degrees centigrade. Decrease in temperature in the evening is 1.5 degrees centigrade. Final temperature is equal to initial temperature plus increase in temperature in the morning plus increase in temperature in the afternoon minus decrease in temperature in the evening. Final temperature is equal to minus 4 plus 3 plus 2 minus 1.5, which is equal to 5 minus 5.5, further equal to minus 0.5 degrees centigrade.
Let us solve a few exercise problems. Click the tab to view solution. Try to solve the problems in the practice zone on your own. You can click solution for your reference. Test your understanding of the chapter by taking the mock unit test.